Hi everyone, this is a video about explaining exponential growth and decay. This is kind of just an introduction to the concept of exponential growth and exponential decay, but let's go ahead and get started. Alright, so exponential growth, exponential decay. Exponential just means something either grows rapidly or decreases rapidly. It basically just means rapid, alright? So some examples of exponential growth would be over here in the yellow. Population. Human population is an example of exponential growth. Mosquito population, rabbit population, anything that grows very quickly. All right, it started out small, then it maybe doubled, then it doubled again, then doubled again, doubled again, doubled again. That's a great example of exponential growth, population growth. A fire, right? A fire starts very small, but if it gets out of control, it can cover a large amount of area very quickly and can be out of control. And then invasive species, for example, mosquitoes, they can grow out of control. Plants, ivy, anything like that grows very quickly. It seems very small, but it gets really big over time. That's exponential growth, all right? Exponential decay are things that over a while, they might be large and they start to suddenly get smaller and smaller and smaller. For example, like radioactive materials. They get small over time. Medications, if you take medicine, so that's either like you need to take it every 6 hours or so on and so forth, because the dosage will decrease in your body. And atmospheric pressure, we breathe okay here, but the higher you get up, the pressure, of course, not being able to breathe, ears pop, so on and so forth. All right. So let's actually get into some problems that deal with this. But we're going to first do the general form of the exponential function. So that's here. Y equals A, B exponent is X. All right. You may see it as f of X. Remember, f of X is just when we're talking about function notation. But we're going to use these synonymously here. All right. So the first thing is, what is A? All right. A is going to be the initial amount. All right, so if I said there were 100 bees in a colony and each year the population of that colony doubles, right? So the initial amount is always A, all right? Then the other variable we have here is going to be B, all right? So what does B represent? B is our base. All right, B is basically telling us what our rate is. So if we say something is tripling, doubling, halving, quartering, anything like that, that is what B represents. So B represents the rate and A represents the initial amount, okay? So the thing is this, sometimes you just have equations they want you to be able to identify if it's exponential growth or exponential decay. So for example, let's say I had the equation y equals 3 to exponent x, all right? So our variable here, x, is an exponent. That's one of the other reasons why this is an exponential function, but we want to determine if it's growth or decay. Well, that's very simple. You look at the number here in parentheses, you look at the base. You look at the base number, all right? If your base is greater than 1, you have exponential growth. If your base is between 0 and 1, you have exponential decay. Your base is never going to be negative, all right? It never will be negative for the base. The initial value could be a negative number, but generally that's just a regular if you're just graphing these, okay? But that is how we determine these. So 2, is 2 greater than 1? Yes, so this one will be growth, okay? All right, let's do another one. What if I have y equals -5 parentheses 1/2 exponent is x? Once again, we want to determine this is growth or decay. I look at the number that's in parentheses. I look at my base value. Well, we look at 1/2. Does 1/2 follow between, is it greater than 1 or is it between 0 and 1? Well, it's between 0 and 1, so this would have to be decay. Okay, let's do one more of these. All right, we're going to have y equals 3/4 parentheses 1.75 to the x power. All right, so once again, we're looking at our base. We're looking at the numbers in parentheses. That's by the exponent. If that number is greater than 1, it's growth. If it's between 0 and 1, it's decay. So when we're doing this one, we look at it. 1.75, is that between 0 and 1? No, it's greater than 1, right? So this is going to be what we call exponential growth. It will model exponential growth, okay? So here are some like word problems that you may see that represent that. So a rabbit colony has a population of 20 rabbits. Each month, the population doubles, creating an exponential model for this scenario. So basically, exponential model is just an equation. So they told you it has a population currently of 20. That's important. And it doubles each month. That's also important. So thinking about 20, it has 20. So this would have to be my starting amount, my initial amount, all right? That's how much you start with. And then it also said that it doubles. Well, doubling sounds like a rate, right? So when we're writing our equation, our y equals ab exponent x, right? Well, remember, a is the starting amount. That's the initial value. And b is our rate. So we're going to have y equals a, which is 20, parentheses, our rate, which is b, doubles. Remember, doubles means times 2. And then our exponent is x, right? So that would be the general equation. So once you get that, you can find out how many rabbits you will have in 10 months, 5 months, 12 months, 1 month. All you're doing is looking at here. So if you remember from earlier lessons you may have had, x is going to represent, in this situation, x is the number of months. And y is going to be the total of the particular thing that you have. That's generally how it works. Y represents some total value that you end up with, right? So let's say I want to find out how many rabbits there were in 3 months, right? So I would take my equation, y equals 20, parentheses 2. But I want to know for 3 months, I'll make my exponent 3. Just put that in your calculator to get your value. Remember, order of operations, do not multiply that 2 with that 20. You will get the incorrect answer every time. So in 3 months, that rabbit population would be 160 rabbits. All right. Do not multiply these two numbers together. Do not multiply this before you do the exponent. You have to do the exponent first. You have to do the exponent first. So 2 to the 3rd power first. Then multiply that value of 20. All right, let's try another one. A stray dog comes into the animal shelter with 3 fleas. If left untreated, the number of fleas will double each week. So once again, we're doubling, right? So this dog came in, it had 3 fleas from the beginning. And then it's doubling each week, right? So double means times 2. So we're going y equals 3 fleas. It's doubling each week. Exponent is x, all right? Same thing if we want to know, this is the number of weeks. And y, of course, is going to be the total number of fleas. So let's say we want to find how many fleas that dog had if it was left untreated for about, let's say, 5 weeks. So we do y equals 3 to the exponent is going to be 5 because that's the number of weeks. So that means in 5 weeks that dog will have 96 fleas. Okay, last example. All right, a peach orchard has 300 trees. That's important. A fungus attacks the trees, and each month the number of trees decreases by 1/4. Create an equation for this scenario. So this time, the number of trees is decreasing, so it's going down. It's getting smaller, so that's going to be exponential decay. So we know it's going to be y equals our starting amount is 300. It's decreasing by 1/4. The number is decreasing by 1/4 each month. And our exponent is x. Okay, so remember, this is the number of months. And this is the total amount of trees, all right? So, as long as you can create the model from the scenario, remember it's the starting point and the rate is what's very, very important, all right? I hope this video was helpful. Let me know if you have any questions. Leave a comment in the comment section. Thanks for watching.